Welcome everyone, back from lunch to the coolest. I believe you actually scored big. This is the coolest room of all the temperature. No, talking about the coolness of your topic. Scott Finneran is an electronics and software engineer with 20-year industry experience developing the hardware and software of embedded systems. He also spent 10 of those years teaching introductory electronics and their interface with microprocessors to TAFE students straight from high school through to mature students looking for a career change. Scott's topic today, which is not up there, design your own printed circuit board using free and open source software. Let's thank Scott.
Thank you. Okay, levels are okay still? Great. All right, basically, as someone pointed out, today, technically we're not designing your own printed circuit board, we're designing my printed circuit board. The next step is to go on to design your printed circuit board, but basically we'll be taking a design from, say, napkin to PCB, to fiberglass with copper on it. And our goal for today is to walk out with an Arduino shield design. Basically the Gerbers and the drill files, which you can send off to somewhere like PCB Cart, and they'll ship you back lovely printed circuit boards for you to solder your components onto. The three things we'll be going through, and we've got a little under 2 hours. I'm not planning to take a break in the middle, so we'll be very much follow the bouncing ball along. So if you need to take a break, just do your thing. While I think of it, the tarball that I asked everyone to download basically contains the tutorial snapshotted at various stages, and I'll do my best to remember to say we're now up to stage 2. That way, if the wheels fall off and you completely lose track of where we're up to, it doesn't mean you lose the remaining hour and a half of the course, so you'll be able to continue following along, hopefully. The three things we'll be doing are schematic capture, which basically means I have a design on a napkin, or in your case an A4 sheet of paper. We'll be entering that into the schematic package, a lot more details of course, and verifying that it's somewhat sane. Then we will basically take that information along to the printed circuit board package, design the board layout, verify that it's somewhat sane, and finally produce what are known as Gerber and drill files, which I'm kind of hoping everyone's a bit up to speed on. Because of the reduced time, I'm not going to be going through a lot of here is what a printed circuit board is, here is how it is made. But basically what we should end up with at the end is a set of files, like I said, that can be sent off to the factory. Now, free software is desperately in need of Pong. I'm sure it was mentioned in Bruce's keynote, and it's what he was getting at, basically.
Simple user interface.
You don't get much simpler than 2 potentiometers and a start button.
Right.
So what we'll be doing is designing a really simple but effective in terms of learning how to do the printed circuit board design Arduino shield. A few simple components on it, and basically, because as we said, simple user interface. We've got a couple of potentiometers, a start button switch for anyone who hasn't played the original Pong in all its black and white glory, and of course an audio and a video connection. Video, for obvious reasons, don't underestimate the sheer beauty that is Pong audio. This is free Pong as it exists at the moment. It's a SparkFun board with a Freetronics proto board on top. As you can see, there's very few components. We've got a couple of resistors. There's the start switch. There's our game controllers, as tested by my 12-year-old and well, at the time, 5-year-old. And here's our AV connections. We'll be talking about RCA connectors in case anyone doesn't know what the heck I'm talking about. These are RCA connectors. Okay, so let's begin. That, by the way, is the end of the slides. If we fire up KiCad, I'm hoping everyone already has, And basically what we'll do is we'll start in the stage 1 directory of the unpacked tarball. And one of the reasons we chose KiCad over probably the other major competitor, well, I don't like to say competitor when it comes to free software, the other major available tool chain, which is GEDA or GEDA, is that this one's a little more monolithic and tied together. So it's purely because it's a little more suitable for a tutorial like this, but functionally equivalent. So we want to create a new project. I've just got it in directory in stage 1, and we'll just simply call it FreePong. Okay. Now the first thing, of course, you'll get, being somewhat experimental free software, is an error message. This is perfectly normal. It's basically saying it's a new design. We don't have a schematic yet. So we've clicked on, sorry, I didn't really explain that. This is a little toolbar of the various tools. This is the schematic package. We'll get to this one. There's our printed circuit board package and so on. So if we flick back to schematic, click OK, and what we've got is, here's our page where we're going to try and basically replicate the circuit that's on here. Now, okay. Now, the first thing you'll often find when you go to do a new design is that not all of the components exist in the libraries that ship with KiCad. Or you may be able to hunt around and find some that somebody's contributed to. I think it's free components. I'll find the URL and get that to you. But basically, you'll usually end up doing some DIY component, some components for the schematic. In our case, the RCA connector. Now, an RCA connector is just a 2-pin connector. We could do it with simply a standard 2-pin connector, but let's do something a little more fancy, something that looks a little nicer. So, first thing we're actually going to do is design the component. If we click on this little somewhat book-like icon, and that's our library editor. Sorry, cart before horse. What we're going to be doing is adding to a library of components that I've supplied. And first thing we need to do is tell KiCad where the library is. This is not one of the standard as shipped libraries. So preferences, library, and we need to add to the search path. And if we go to where we're working in stage 1, it's purely a nomenclature thing, but the schematics use libraries and the printed circuit boards use modules. Select the libraries directory, click open. Do we want to use a relative path? Yes. Basically, if we move the project around, or if we were to drop this into a repo somewhere and someone takes their own copy, it won't get all upset that their username isn't the same as yours and so on. So yes for a relative path. Now what we need to do is add to our list of libraries. It's been imaginatively named myparts.lib, and just click OK, or open, and we're OK. Because we've changed the project itself, the configuration of the project, it's going to ask us repeatedly. We'll get asked a few times, yes, we want to save the project configuration. Okay, now we are ready to click on the library editor, which is the little book-looking thing. If anyone has an earlier version of KiCad, you may find that the icons have changed a little. The mouse over help tends to be your best bet. And here's our library editor. Something that can help with laying out things is if you change the cursor shape, and you end up with an expanded cursor. It's helpful for lining things up, basically, and keeping things neat, which is a big part of doing a schematic layout. I'm going to turn that off simply because it gets really confusing with this dirty great blue cross in the middle of the screen. Now, our RCA connector, as we said, is basically a pin with a circle around, with a shield around it. So, if we go to the centre, first we need to tell it we're actually editing a component. So we select our working library, which is, we're going to drop this into the My Parts library, and we're going to create a new component. Now, with a component, what we're not making the RCA connector for our circuit, we're actually making an RCA macro, if you like. It's a lot like we're making stamps. We're carving out the rubber side of the stamp. Now the component name, we'll call that RCA socket. Integrated circuits are traditionally U1, U2, U3, resistors R1, R2, R3 and so on. In the case of connectors, I've used P for port on the schematic. That's just a habit of mine, but if you wanted to use con or something or other else, to keep things simple, it may be worth keeping it at P for now. So our prefix is P. The package will then append numbers as we go. Number of parts per package, in our case it's 1. An example of 4 might be a logic device which has a number of gates of an identical type in it. Basically we keep the defaults. And click OK. And what we notice if you look really carefully is some quite tiny writing. There are a few things you can do with the mouse, but after a while the keyboard shortcuts are infinitely faster. Pressing home will zoom in on the entire design you're working in at the moment, which in our case is just some text, so it's really up close. By the way, if anyone has questions, please, this is definitely a tutorial, let me know.
I just missed out on a few things.
Sure.
Just with the component properties.
Yep. Oh, how do we edit them again?
Just what the default
Yes.
purpose designator and if there are any changes below that.
No. The only thing you need is the name, and the default designator is a P. If you have a look on the schematic, I don't know if you've got a handout there.
Yeah.
Okay. We've got 2 RCA connectors on the right-hand side, and there's P1 and P2. So the generic, or the prefix is P. Now, what we've actually got here are 2 labels. If you can scroll out with the mouse wheel. And,
What's going to zoom in and out?
pardon?
What are the hotkeys for zoom in and out?
F1 and F2 sounds about right. I usually use the mouse wheel, so if you're looking for hotkeys, preferences, hotkeys, why it's under preferences, I don't know. It should be under help. List current hotkeys. Conveniently located in a secret place. What was it, in the filing cabinet in the basement? Anyway. Okay. What we've got are a few labels. One of them is the component name, and the other is the designator. Because we're designing that stamp, we've literally got to place everything, including where the text will end up going. For the moment, let's just move it out of the way. You can right-click and select, or here are the shortcut keys, which I would encourage you to pick up. So there's our name, or with an M. There's our designator. We're just moving them out of the way for the moment. The crosshairs, blue crosshairs, are basically coordinates 0, 0, 0 as far as the component goes. So if we centre the component around there, when we do actually place a few of these in the schematic sheet, they'll fit. So, need to move along. Okay, so as I said, concentric circles for our RCA connector. If we go over to the side, we want to add some circles. It's literally draw the picture. So we've selected the circle tool, click in the centre, and before we go on, or while you're finding that, printed circuit board design is done in inches. You can do it in millimetres. More accurately, you can do it on your own in millimetres. Both professional contractors, hobbyists, everyone does this in inches, or more accurately in thousandths of an inch. Data sheets are always specified in this. We're not going to win this one. It's best to choose our battles there. Basically, you'll see all measurements described in thou, as in thousandths of an inch, or mils, which I think is actually basically milli-inches. And unfortunately, I tend to use the terms interchangeably. I'll try and stick with thou. If we have a look over here, we've got our coordinates for where the cursor is. And this is really handy because what we actually want is, we want a circle at, I did write these down just to make things a little quicker, at 50. So we've moved 50. Sometimes using the keyboard to get a more accurate placement is a lot easier than a mouse. And
When you click on it to start the circle, then you can switch to the cursors and step it.
yes,
down.
yep. So click, position, and click to lock it in. Put another one at 100, and this is the barrel of our RCA connector. Back to the centre again, and another at 300. Starting to look a bit like what's on the page now.
300 is milli.
Yes, yes. Now, on a schematic, it's probably not so critical. You could switch to millimetres if you wanted to. With the printed circuit board itself, which is a physical design, that's when we really need to stick to thou or mils.
You'll find the term inches a lot of the old dip chips, they're 10th inch spacing, and
Yes.
you can't change the chips, they're already on the market, but quite stayed the same.
Yes. And there are conversions, but it's never a nice, easy, neat conversion. If we wanted to, pressing the home key will somewhat clean things up for us as well. Something else that's really common to EDA tools, and I'd love to get someone who could explain it to me as to why, they tend to leave rabbit droppings. It's known as the page doesn't always get repainted, and I suspect it's because historically there's an awful lot of maths behind what's being presented on the screen, and so rather than being absolutely particular about getting the most beautiful screen, the repainting efforts, it's that 80-20% effort then. F3 will repaint the screen as it is, simply but a complete repaint. F4, what is F4? Ah, yes.
If you do a circle wrong, how do you delete and start over?
There's a little eraser tool, and the circle itself is an entire entity. It's not a erase the line kind of deal. Yes?
I don't know what to do, right click on something.
That's probably the best tip for KiCad. If you don't know what to do, right click on something. One of the things you may find is that you are asked what it is you're clicking. You may, if there were two entities overlapping, you may get a little context menu saying which one are you actually clicking on. But okay, so now we want to whack a couple of pins. Now pins are the most important thing because this is where we make our interconnections. Adding the pin component is up here. Okay, rather than chew up time, we might just go with 0.8 and pretend. Okay, so a few things we're going to be doing is we'll be running tracks, amazingly. We've got our track tool, and the best way to do this in most cases is this one is your friend, highlight net. Choose a net, any signal, and this will tell you all of the pins that need to be connected. So we want to run a track, and it leaves the tracks highlighted, which is nice. So it's click, and just simply a click when we need to turn. Anyone who's used something like Eagle or ProTel, this is very similar. Pardon?
How do you change the track once you made it?
In what way change?
As in, you put an extra kink in it, you want to get rid of one of the kinks as it backs a bit. Or change, say, you want to move where that slanty bit is, say, a inch to the left.
Pardon?
So you want to just move the slanty bit an inch to the left.
You can drag segment, that sort of thing. And more options as well with the right click. Now, I'm basically going through running tracks fairly quickly. This one's a bit of a doozy, so we might...
What tool were you selecting when that happens? I can't see that option on mine.
So to run the actual tracks,
To edit that to move segment, whatever it was.
if you right click, brings up a context menu.
That's got like change track width and thing,
No drag track.
no.
If you'll first need to select your little arrow tool. Actually, it wasn't even on there. It must be zoom select, grid select. Yes. I just did it with the basically selecting with the arrow and then a G to drag. So what we do is we go through, we run our tracks. We, in the case of, let's say 5 volts, we have kept our 48 volts, our 48 wide tracks. Now, something we may find is that after we've run our tracks, we could find that we need to hop over. So what we'll need to do is how do we switch layers with vias? And so by running, let's just choose a net. We place a track, zoom in a little, and if we did need to switch layers, V for via, or we use the via tool, and that will switch copper layers and also place the plated through hole. We can add another if we prefer and switch back. And so there's our net running through multiple layers, and that'll let us that's why it's not letting me do that.
Is there a version of the resistor footprint that just mounts it on its end rather than flat?
I don't think so. You mean totem pole style?
Yeah.
Not that I'm aware of.
So how do you think to be able to do that?
It is. You could just choose one of the very small capacitor kind of footprints or copy that component and rename it.
That's one of my frustrations. I quite often do that.
It's a pretty trivial component to make.
Yeah, I realise that. Obviously, nice to be consistent and standardised by everyone else.
So it's basically a process of placing the tracks, Now actually something we can do is crash the printed circuit board.
You get a transcript?
Pardon?
Do you get a transcript of this?
A transcript.
Yes. Render graphics gives you a transcript from the window. So you can just select all the things in there and play that back into the things before you run them.
Not that I'm aware of. It should be possible because as far as I know the undo information's unlimited, and so it would be possible to generate from that. I hadn't thought about that. Might be a nice change to make. Okay, and as you can see, that's the last step. Let's Okay. Now let's pretend that I elegantly and without any problems was able to run all of the tracks. One of the things that's really nice to be able to do, and it's one of the features I wasn't expecting it to have, is to do regions, or filled zones as they call them. We simply select which layer. In this case we want it on the front layer. We want it to be a ground plane, and we
Square record
Mm.
after the course.
And by drawing an enclosed space, this is definitely one of those activities where the faster you go isn't necessarily the sooner you'll finish. But once you've got an enclosed space, you end up with this hatching pattern, and you can simply right-click and fill zones, and you get the full painted in, and that's an entire copper ground plane.
That's the way to do a polygon for is that
Yes. You select a region. You can do multiple regions. They can overlap. It's that sort of thing, and you can do a polygon. I did just a rectangle, but that was pretty much it. Looks like we're pretty much out of time, unfortunately.
Unless people want to go through afternoon tea, and unfortunately I actually have to go somewhere else during afternoon tea, I'm going to, on behalf of the LCA organisers, give you a thank you gift.
Thank you very much.
Thank you for the tutorial. And thank you. I'm not sure what my AV team up there is going, whether they're going to continue to tape.
No, that's
half
perfectly.
an hour or something before the next talker is speaker is in here.
What I would what I'm going to offer then is just because everyone's got places to be. If we went for another 5 or 10 minutes for anyone who wants to hang around, if there's anyone who's really keen to finish things off in a much more slow fashion and wants to grab a hold of me, maybe we could get one of the BOF rooms and I can go through at a slower pace. We could possibly even work on one of your PCBs. All right, thank you very much for your time, guys. No, it's...